Hi, everyone. Thank you for joining us today. My name is Jennifer Feller, and I'm the Business Development Manager at Enthalpy Analytical, and I'll be today's moderator. This is the third and final webinar in the END series. Today, we will discuss END's battery and device safety requirements. This presentation is about 40 minutes with a Q&A session at the end. We invite you to submit questions throughout the presentation in the chat box. Please note this webinar is being recorded. With that, I'd like to introduce our panelists. Doug Burton is the CEO and Principal Engineer at Device Safety and Reliability Group. He's engaged in safety and reliability engineering for e-cig devices since 1997. Doug has extensive experience in, but not limited to at all, product risk assessment and mitigation, hazard analysis, human factor analysis, or HFA, manufacturing facility assessment and improvement, lithium-ion battery testing, and battery cell manufacturing facility auditing. As a senior principal engineer at Altria, he developed their hazard analysis program, integrating hazards testing, HFA, and user guide construction to create a process to safeguard consumers from potential hazards. Doug is also an original member of the UL 8139 Standards Technical Panel, which is charged with the creation and development of the first American national standard for electrical systems of e-cigs and vaping devices. With us, we also have Ethan Sill from the Vape Lab at Enthalpy. Ethan is the aerosol group leader and has extensive experience operating and testing END's devices and batteries. He's been with Enthalpy for over 5 years and holds a Bachelor of Science in Biochemistry from Christopher Newport University. And without further ado, I'd like to let Doug go.
Okay, well, I feel privileged to be here with you today. And so what I would like to do is share some things that I've learned over working with e-vapor in China for 6 years and working on PMTA submissions and working on deficiency letter answers to give you some idea of what you might have to gather together to support a PMTA or a deficiency letter. So with all of the things that you have to do to create a PMTA, it is really easy to forget that the battery system has to be appropriate for the protection of public health also. And this is not new. This has been FDA's position all the way back to when the draft guidance for industry was issued in May of 2016. And basically FDA said that they're concerned about the risk of the batteries and ends, and that many different aspects of the batteries can cause risks such as leaching of battery materials, battery explosions, or other defects. So what we're going to talk about today is some of the information you can use to provide evidence that your system is appropriate. So first of all, who are you? These are the folks I think that really need this type of information in the PMTA activity. Maybe you've been in business for a long time and you buy your products from a foreign supplier and you don't do much product design. Basically, you're pulling things from a catalog that your supplier offers. And now all of a sudden you need detailed technical information to explain how your battery system works. You may also be somebody who submitted a PMTA on time, yay you, but you now have a deficiency letter. And if you did not characterize your battery system very well, you probably will get one of those. The FDA sent you questions about things and you don't know where to turn to get the information you need or where to start. Or maybe you are an adept electronics person and have designed all your systems yourself, but you don't have a process or a source for testing and certifications that you need, and you don't necessarily know what to tell your consumers in your product documentation like your owner's guide. So we're going to try to dig into that a little bit. So first, when we talk about an ENDS battery system, this is a block diagram that kind of identifies the subsystems that we're talking about. So kind of starting at the wall and working forward, a rechargeable ENDS will have either a charging power supply that it provides, that the manufacturer provides you with the battery, or it has a provision like a USB port for you to charge it with your existing USB power supply. Within the enclosure that is designed to protect the battery cell from physical damage and to provide a mechanism for pressure release if the battery fails. You'll also find in there charge regulation, which makes sure that the battery cell is charged properly. If it's not charged properly, it can be a hazard. There'll be the battery cell itself, which is typically a lithium cobalt ion cell. There's discharge regulation to make sure that you don't discharge it at too high a current rate that can damage the cell. And there's processor, firmware, sensors that keep the battery cell effectively comfortable. So you've got the wall power conversion, physical protection, pressure release mechanism. You've got temperature limits that are imposed on the battery cell. Basically, the cell is comfortable when you're comfortable, but we'll talk about that a little bit. You've got firmware that determines how your system reacts to different requests, commands, and conditions. And then the heating coil is the source of load on the battery system. And that's important because if the resistance is out of specification, you can again overload the battery cell and cause issues. Now, a couple of special cases on ENDS battery systems. There are non-rechargeable ENDS. So when you have a non-rechargeable device, basically a whole class of potential hazards are eliminated because you're not recharging your battery. Now, some of those types of devices lack the charge regulation feature. Some of them are actually completely rechargeable devices that just don't have connections for you to be able to charge the device. But the key there is there's a whole class of tests that don't apply, and certifying the device may actually be easy. The other special case is ENDS that have reusable, user replaceable battery cells. And these are an issue because the batteries that are typically used in these, and you may have heard of an 18650 battery. It looks a lot like a AA alkaline battery. Those batteries are not designed to be handled by consumers. They are designed to be included in battery packs like tools use, and they're not general purpose cells. They do not tolerate handling by consumers well. And frankly, the strongest driver of battery incidents and explosions between about 2014 and 2017 was people putting these battery cells in their pockets or otherwise abusing them and having a battery failure close to their body. It produces significant issues with property damage and personal injury. And the system standard we're going to talk about in a few minutes specifically disallows this type of ENDS device. You can't get a certification for it. So the causes of these batteries failing, which is basically what we're trying to avoid, fall into kind of four categories: external mechanical overstress, external electrical overstress, external thermal overstress, and cell internal faults. So the first three of these categories, you can engineer your ENS battery system to protect the cell against these things. Vibration, shock, and drop, or physical damage to the cell can be avoided by arranging the components of the system well and making the enclosure strong enough to put up with basic insults. Overcharge, short circuit, and over discharge are electrical problems. Overcharging can produce very severe results in battery failure, because the battery not only has the energy it has to cause problems, it's still taking in energy from outside. A short circuit is basically an overdraw of current from the battery, and in the absence of protection, some of these batteries can fail pretty dramatically in a short circuit. Over discharge is where you pull the battery voltage down through use below its minimum recharging voltage, and the battery can become unstable when it's recharged at a voltage below where the minimum recharge voltage cutoff is. Over temperature or under temperature are situations, you've heard, don't put this device next to open flame, don't put it on your radiator, don't store it in high temperatures, don't leave it in the car overnight when it's really cold. These temperature conditions can, you either at high temperature, you can have an overly active chemistry of the battery, or under temperature, the battery chemistry is so slow that the battery cannot accept the charge, and the lithium can plate out and eventually pierce something called a separator, which is between the two electrodes, and cause a short circuit internally. One thing to remember here is the first three categories your device design can take care of. Cell internal fault, there is nothing your device design can do about that. And so that is why you might consider having somebody audit your battery cell supplier to make sure that the process is producing safe cells and not defective cells. So an audit will look at raw materials, cell design, the separator design, the manufacturing process, the cleanliness of it. And then you need to consider how the battery changes over time as it's used, and what happens to it if it is subject to incidental overcharge, undercharge, or methods of use and mistreatment that can gradually damage the battery.
So Doug, can I ask a quick question? In your experience, what is the most common cause of failure?
So broadly, the most common cause is where the battery is removable and not treated well when it's out of the box. Otherwise, if you don't manage the electrical employment of the cell properly, then it can become less safe over time. Also, internal faults in the wiring, printed circuit boards, or structure of the battery assembly can cause failure also, and some manufacturers have had to deal with that. So what do you do about that? So your battery cell supplier will have something called a battery specification sheet. And that battery specification sheet should be the foundation of your ENS battery system. It defines the levels of voltage, current, and temperature under which the cell can reliably and safely perform over its intended lifetime. The FDA is interested in seeing what the normal operating region of your battery is, and then having you verify that your design stays within that operating region. Now, this table is an excerpt from one of these specification documents, and you can see where the discharge cutoff voltage is, the limited charge voltage, the maximum voltage at which you should stop charging the battery. It's full charge there. A standard charge current and a maximum charge current, which 99% of devices actually charge at the maximum charge current, and the maximum discharge current. So if you are exceeding any of these values, your device can become less dependable over time, and quality of initial manufacturer goes to quality over time, which is reliability, which goes to safety. They're not separate issues. They're all a continuum of safety. But the basis of this is the battery specification sheet, and you should send it with your PMTA. So battery cells are kept safe by testing them against battery cell standards. And there are two in particular that you'll encounter in your PMTA activities. The first one is an older standard called UL 1642. UL is Underwriters Laboratories, and it is entitled Lithium Batteries. Its newer and bigger brother, which has more and more been adopted as the minimum standard for cell safety, is IEC 62133-2. Secondary cells and batteries containing alkaline or other non-acid electrolyte safety requirements for portable sealed secondary cells and for batteries made from them for use in portable applications. That is a very catchy title. You should probably just remember the number. But in any case, these cell standards include an evaluation of how the cell is constructed, how the cell performs under, let's say, normal conditions, and then they have tests for electrical, mechanical, environmental, and fire exposure situations that duplicate or simulate the failure generating scenarios, because the cell under these standards is required to be able to tolerate these without generating fire explosion. So ENS devices sort of have their origin in the time frame of 2007, at least as we know ENS today. For a long time, there was no battery system safety standard. In 2017, the FDA and Health Canada and the United States Consumer Product Safety Commission, in response to increasing battery failure incident frequency, requested that Underwriters Laboratories develop a standard to improve the safety of ENS electrical systems. And that is UL 8139. The process started in 2017, fully 10 years after these products started to catch on. And the first version was released in 2018, and it was revised again in 2020 with some improvements to testing. But it's a very comprehensive standard. It can be used as a guide for system design. It includes tests to verify and importantly document system performance on a pass-fail basis under failure conditions. So This is a very useful thing to help you describe your battery system. So as of September of this year, 34 companies representing 90 different products have obtained certification to this standard. So it's not impossible. You can argue it's not even difficult anymore. But you should be aware that if you have a system that you've been selling and you want to upgrade it to this standard, it is usually more difficult to upgrade an existing product than to design a new system from scratch, even if you put it in your old enclosure.
Sorry to interrupt, Doug.
No.
But so I have a question. How long has it been incorporated for these manufacturers of these battery cells and products to seek this approval and to obtain the certificate?
2018 was basically the first year you could get a system certification under 8139. So
Okay.
prior to that, if you wanted to make sure your system was safe, you had to borrow standards from, say, cell phones or laptop computers or parts of them. And that didn't work so well because the thing that makes the end system stand out is it pulls a lot of current from the batteries, whereas cell phones and other systems do not. But this standard is sort of a gift, if you will, to the smaller manufacturers because they don't have to go through that really expensive process of trying to build their own standard. They can certify to this one and pretty well meet requirements. It'll be much safer. It'll be a much safer product than in the old days.
Good. It's good to know. Thank you.
So I was working with a client who has a successful product, a relatively simple product. And she told me I had no idea that all of this stuff was underlying my product. And that's kind of the reaction you see when you go from doing business to having to explain to a regulatory body how your stuff works. And so this is a list. There may be some other things that need to go on this list for individual systems, but this is a fairly comprehensive list of things that you should expect to include in your PMTA. The battery system certification under UL 8139, if you have it, you'll want to include the confirmation letter from UL. You want the certificate document, and you'll want the test report. And you should include the test report in your PMTA write-up to explain how the test results reinforce the safety of your particular system. So same thing for battery cell certifications. You need the confirmation letter, you need the certificate, and you need the listing document. UL provides a listing service where they identify cells and components that have been tested and certified. As we discussed a little earlier, you need the battery cell manufacturer's specification data sheet. This should be readily available from your cell supplier. It is the basis around which the rest of the safety activity is built. The battery cell MSDS is needed because you need to explain the chemical contents of the cell. We know about e-liquid components that we need to explain what's in the e-liquid, but sometimes we forget that, especially when electronic components are in contact with either the e-liquid or the air that is drawn into the consumer's mouth, we need to account for the chemistry of those components also. So, especially if you have a non-rechargeable ends product, you may be asked for a battery shelf life study. And the reason this is important in terms of a non-rechargeable ends is everybody thinks about shelf life in terms of e-liquid stability, but on a non-rechargeable ends product, the day you put it all together, the battery voltage starts to decline due to internal discharge of the battery cell and due to quiescent current or idle current, if you will, applied by the control circuit in your ends product. And you'll need to demonstrate that the battery will not drop below the minimum discharge voltage during the declared shelf life of your product. This is not a difficult shelf life study to execute if you can obtain devices that have been produced at 3 separate production dates, and you know the time between the test time and those 3 dates, you can provide a very reliable voltage decline graph that will explain and hopefully reinforce the fact that your battery shelf life is at least as long as your e-liquid shelf life. They will ask you about battery protections related to dry puffing. So dry puffing, while it is not super dangerous to the battery cell, if it results in any opportunity for combustion anywhere in your device, that is a threat to your battery cell. So actually, Enthalpy can help you perform a test called an end-of-life puffing test. And the idea is that they run your samples on a smoking machine until the battery indicates that its charge is depleted. So they can also, at that point, as the battery is being puffed, they can measure aerosol mass, and that'll tell you if you have an issue where the battery way outlasts the e-liquid and dry puffing is significant, or the risk of it is significant. And you can also report the relative flame resistance of the components near the heater core. The heater resistance is important because it determines the load on the battery cell, and if it's too low, the battery can be over discharged or pull too much, or you can pull too much current from the battery cell. Control system component data sheets. Some cases you can buy a single integrated circuit charging control system, for example, but the operating parameters of that part have to match the limits on the cell data sheet. So any control system component, you should be providing operational descriptions and the limits associated with those control system components. If you modulate the voltage on discharge, discharge voltage modulation is sort of like turning the battery on and off really fast, producing an average voltage that is lower than the actual cell voltage. You'll need to explain that scheme, or if you have another output limiting process, you'll need to talk about that. And finally, failure mode effects analysis and human factors analysis or evaluations can determine what consequences your consumer will face if the design fails or if the consumer uses the device wrong. And I'll talk a little bit about each of those because they're important. So FMEA, failure mode effects analysis, goes back to military processes in the 1940s. And it's a way to connect a failure within your design to the consequences that the consumer would see if that failure occurred. If you tell the FDA that your device hazards are mitigated by the design of the product, you're going to need to provide an FMEA as evidence. So the American Society for Quality on their website has an excellent description and almost mini tutorial on failure mode effects analysis. So I highly recommend it. But the basics are you gather a cross-functional engineering team. Diverse knowledge about the product is critical. This is not an analysis where you lock your lead designer in a cubicle and he sits in there for a week and comes out with this. The diversity of a team is important to make this work. You break your product down by functions and systems and subsystems and components. It's a taxonomy. And you identify ways that the failure can occur. And this is the value of a diverse team, and it's a critical element because the way an FMEA can fail is that you neglect to collect all of the potential failure modes. Ideally, you would identify all possible ways your device can fail. You assign those failures probability of occurrence, severity, and the ability of the consumer to detect the failure if it's occurred. And then you assign numerical values to those. You combine them usually by multiplication to a risk priority number. And you take the issues that have the highest risk priority number, or RPN, first, and severity is always king. You identify ways to reduce those risk priority numbers. You assign responsibility for actions related to those mitigations and target dates for completion to create accountability for getting the work done. Once you've done it, you go back and look to see how far your RPN declined. So working with Chinese suppliers, typically they will have completed an FMEA, but what you might find is that the scope of failures or failure modes that they've considered is not broad enough, or not what we might expect in the United States. And it's perfectly acceptable for you to ask them to revisit it. You can go over it with them and make suggestions. The key is, if you add anything, you should identify it as having been added at your request, because the FMEA usually occurs early in the design process. And if you're asking for a supplement, you're doing it kind of ex post facto. So you need to tell them what you add.
So Doug, what is the average timeline for one of these to be completed from start to finish?
Start to finish this, it really depends on the complexity of the device, but you can expect for a complex device, it could take a month to get this done with 4 or 5 engineers working on it.
Okay.
So, in a similar vein, a human factors analysis, there are sort of variations on this, but basically the idea is that the public is a very innovative group of people, and they will find ways to interact with your product that you had no anticipation of. And so human factors analysis is a way to identify what they might come up with and anticipate and guard against these innovations that create negative consequences. So again, you need a diverse team, but in this case, what you're looking for is people with varying levels of familiarity with the product. So human factors team might have designers responsible for the product, all the way down to somebody who is not aware of the product at all, and this is the first time they've seen it. And you want people like your toxicologists and your law department involved, because they will pick up on things based on their existing expertise. It is critically important to have an independent third-party facilitator for this activity, somebody that has no responsibility or stake in whether the product succeeds or not. Ideally, this person will have a cognitive sciences background and also product safety experience, and will be an experienced facilitator. So the team essentially plays with the product, and a scribe records what people learn. And then you list the potential hazards and compare hazard levels to data available in public injury databases. So I will give you an example of what happens. We were running an HFA on a product, and a lawyer picked the product up and snapped it like a pencil. Not something we really anticipated, but what we learned is when you did that, the battery and the circuitry was exposed and came out to where the consumer was able to access it. That's not an acceptable situation. So we had to re-engineer the connector so it would snap without exposing the battery. That's just one example of the type of thing that you can learn when you expose your product to people who don't have a lot of sensitivity or frankly concern with it. It's a very valuable tool. So that leads me to the owner's guide. So what should it say, and how do you ensure it addresses the items that are really needed? So owner's guides tend to be part of the promotional literature that goes with the product, but it needs to have appropriate instructions and warnings so that the consumer can interact safely with the product. So where do you get the information? Well, the FMEA that we just discussed and the human factors analysis we just discussed are a great place to get the raw data for risk analysis that will help you construct instructions and warnings that will work well for your consumer and keep him safe, and to place in the owner's guide. So if you need help with instructions and warnings, there is an American national standard called Z535.6, and that can help you with language and what we call signal words. Signal words examples are danger, warning, and caution. And 535 will help you employ those words in an appropriate and consistent manner. So as promotional material, you will run into folks that don't want you to be too direct or scary in your warning language, which is understandable. But in instructions and warnings, you need to use direct, simple language. For example, I don't think the word should belongs anywhere in instructions and warnings. I mean, you're not communicating, you should do this, or you're a bad person. You're communicating, if you do this, you can put yourself at risk of personal injury or property damage. So simple, direct language is important. Illustrations nowadays are much easier to make since the advent of computer-aided design software, and they are very helpful to basically integrate what you're telling the consumer with words to what they need to be able to see and feel when they follow instructions. placement of the warnings and instructions. Frequently they are put up front. And some people have argued that that's great because it gives everybody one place in which to ignore all of that information at one time. So there is some discussion as to whether you put the warnings in a panel in the front, which you see in appliances and tools, or you spread the warnings additionally throughout the instructions as the consumer encounters things that may pose a hazard if they're done wrong. And finally, it's worthwhile to engage in a comprehension study where the owner's guide is exposed to people who've never seen the product. They read it, you quiz them on what they learned, and then you can adjust your content according to what the consumer is understanding. So for PMTA, you need to get information from your suppliers. From doing this over the last few years, I've found some things to be helpful. So you should establish a dedicated information channel. Basically, one person on your team, preferably a technical person, communicates with one person at the supplier, which typically in China is going to be your account sales representative. That person is in a very powerful position because he represents you as the customer who pays him. So he can get engineering information, all of the information typically that you need. If you can, it helps to provide a comprehensive list at the beginning so that he can turn his coworkers loose and gather all of this stuff for you. Bear in mind that inevitably you'll review it and want more things, so you need to have a good relationship with this person. And it may help you to provide examples in case what you're looking for is called something else by the company. You can show them what it looks like and they can say, okay, I understand what you need. But in this process, almost inevitably, you're going to find a sub-supplier somewhere that says, no, that's proprietary information. I can't give that to you. And my reaction is basically, well, no, because to properly execute your PMTA, you're going to need everything that's important, and that includes whether it's confidential or not. So some of the responses I've been known to use are, one, if I don't get a market authorization, I don't need that supplier anyway, so it's in your interest to give me this information. Number two, PMTA is a reasonable opportunity to replace suppliers that are not forced company. And thirdly, FDA obtains and protects confidential information all the time. Frankly, in the hands of the FDA, your information is probably more secure as a sub-supplier than it is with the folks you're selling what you make to. So there is no real excuse for your supplier not to give you the information you need. So finally, PMTA deficiency letters. I've worked on a couple of these. Number one, it's not bad news. It's 1,000 times better than getting an MDO, a marketing denial order. And it's an opportunity for you to improve your application. You might only get one chance, though, one bite at the apple. So go through the letter, identify and make sure you know what to provide, and make sure that you provide exactly what they ask. And if what they ask for isn't the complete picture, complete the picture with additional information. Sometimes they'll ask you for things that are not really applicable. So you need to explain why they're not applicable, excuse me. An example would be they want to know what your specified heater coil temperature is. And probably you don't have a spec for that. It's a dependent variable that's created by the other things that you control in the design. But you may have to tell them, with data what that number ends up being. So the last thing I can tell you is, if you get a deficiency letter, reach out, get help. There are companies that can help you answer these questions and dig down and guide you to the correct depth of data to provide and write for you suitable explanatory responses to the questions. So now Ethan is going to discuss an interesting proposal for a reference platform for analytical evaluation of e-liquids. Ethan.
Yes. So as you can see, Caresta published a technical report in January of 2021 covering a collaborative study done in 2019 on the Evolve DNA 75 color reference mod. This device is very, very customizable and easy to use. And there is a software that can be connected to this device to show all types of the puff profiling of the previous testing, and it lets you modify and kind of give you something similar to the device or e-cigarette that you're trying to manufacture. These things have been recommended for reference as a reference standard for all of aerosol products. And that's it.
Thank you, Doug. Thank you, Ethan. We'll now go to our Q&A session, and I'll start with the questions that were in the chat box. And then I think Ethan has some questions that were emailed ahead of the presentation. I'll just go in order of the chat box. Do lithium button cells, this is for Doug, do lithium button cells have enough current density for e-cigs miniaturization?
Typically, no. The current carrying capacity of a lithium ion cell is typically directly related to the volume of the cell. So the alternative to having volume is to wrap the electrodes and separator tighter, which at some point doesn't produce a very safe outcome. So as they are known nowadays, button cells and coin cells, the difference being button cells are not rechargeable and coin cells are rechargeable. They just don't have enough volume to provide the storage capacity and current capacity for long enough to be practical for a e-liquid device.
Okay. Next question, do you expect any negative impact of e-liquid leaking on the safety of effectiveness of battery systems?
It is to be avoided because while typically an e-liquid is not in itself conductive, it can carry water, number one. Number two, it can basically occlude air passages in the product. And number three, over time, it can attack some of the circuit board components chemically. So that is something that you should work hard to avoid.
And then my next question is actually for Ethan. Doug had mentioned how we do end-of-life testing at Enthalpy. How often do we change the pods when we do battery end-of-life testing specifically to see how long the battery lasts?
Well, we can do it a variety of ways. We can use multiple cartridges and pods with the same battery over time and just change after a certain amount of puffs per block, or you can just use the same pod and take it until the battery dies if you're not analyzing for certain analytes.
Off the top of your head, can you remember how many times you've had to change a pod if you were using the same battery?
Um, it all depends on the amount in the pod. So the pod capacity is the pretty much underlying factor of that.
That makes sense. And then in the chat box, I have one more question. This one's for Doug. Is there any correlation between the battery safety and the battery size in terms of the games?
So the battery size can determine the amount of damage that's possible, the amount of property damage, the degree of personal injury. But the same level of care needs to be executed for small cells as for large cells. In the case of multiple cells, you have the additional challenge of balancing. If you have two cells, they need to be of either very, very similar internal electrical resistance, or you have to have a circuit that can balance the charge rate of the two cells. Otherwise, one will always be overcharged and one will always be undercharged, and the overcharged cell will degrade faster than the undercharged cell. Eventually, you can have a situation where one is in reasonable shape and the other one is in a dangerous condition, and the still viable cell will accelerate the rate at which the other cell becomes dangerous. So, as one of my testing associates likes to say, size doesn't matter. You still have to protect them all.
Do these get recycled to reclaim the lithium metal?
That is a technology in various states of development. There are organizations that offer to basically take your cells back, and to some degree they're recyclable, but that is still a technology that's on the upswing. It is, however, a very valuable technology, considering on your desk right in front of you right now, you may have 5 or 6 things that are operated by these batteries. So reclaiming the lithium, which is a limited resource, is a good idea.
And then Ethan, I think you have a list of questions that were submitted beforehand, if you don't mind reading those off for Doug.
Absolutely. I have one other question to add. Doug, what is the longevity of these lithium ion cell batteries? Like, is there a recommended use or time frame that they should be used for?
So most of the ones, the cells I've worked with specifically, have a quoted cycle life of 300 cycles.
Okay.
So that means you can charge and discharge the battery 300 times.
Okay.
So if you think about that a minute, if you're using an e-vapor device and you charge it once a day and you discharge it once a day, you're limited to about a year. And what's going to happen as that cell ages is its capacity will drop. So in terms of, say, puff count, at first you might have gotten 500. After a year, you could be down to 200. And you might, it's probably a good idea to think about getting rid of that device and getting a new one. This, unfortunately, is one reason why the replaceable cell models have a tendency to, people see this as an advantage that you can replace the cell. But the dangers involved in handling the cell, not because the cell is inherently dangerous, but because it's not designed to be handled this way, outweigh the fact that you might have to get a new device every year or so.
Okay. So from your experience, which product type do you think has the most battery issues?
You might detect a theme developing here. I think the ones that allow the consumer to access the battery and handle it have the highest rate of serious incidents. There have been a few older model designs that have failed because of manufacturing defects that weren't picked up by the retailer. But most of those are behind us. So I think the replaceable cell versions are still the biggest issue.
So with that being said, do any mod systems have certification?
Yes, but typically a mod that gets a certification under UL 8139 will have permanently installed batteries. The ones with batteries that can be replaced by the consumer actually fail a specific requirement of 8139.
Okay. And does each component of the power system need to be certified? For example, the battery cell, the board, and the coil, anything in the airflow path?
So there are various types of certification for components. There is system certification, like we've talked about. The batteries have specific standards they need to meet. Other components, you are better off if you select components that are called recognized components. UL has a process where they have reliability testing executed on, say, transistors and other power sensitive components. So you can consult UL and verify that the one that you're using is recognized. Also, there are some advantages given to you when your device is tested if you use a recognized component. So that way there's one less thing you have to really worry about and one less thing you have to explain to your insurance company, for example.
Okay. And of those 34 companies that are representing the 90 that you spoke about earlier, are they publicly available to consumers or engineers or anyone?
So the information about the certification on the packaging of the product, there will be a mark, a UL mark, that indicates that it passed the system certification process. As to finding out who is and who isn't certified, UL has a web resource called, let's see, it's called Product IQ. And that is a paid service. You sort of have to qualify to get access to it. It's not considered to be a consumer resource. You have to be kind of in the business, or, for example, since due to the type of work that I do, I have that service and it costs me about $100 a year. But if you're doing the type of work that I'm doing, it's a very valuable resource. So.
Okay.
So Ethan, I think we have time for one more question.
Okay. So what services does your company provide?
Facility auditing, writing for deficiency letters and PMTA sections. I can coordinate your testing program for cells, and I have a network of folks that I do work with that I can direct you to if you have specific needs.
Perfect.
Okay.
So, and if you have any questions, just let me know.
Yeah, that sounds great. I think that's all the time we have today. I just want to thank Doug and Ethan and everyone who joined today. We really appreciate it. We're going to be sending out an email with a copy of these slides and the recording once available, including Doug's information if anyone has any specific questions. So just take care and stay safe, and we hope to see you again at the next webinar.
Thanks, folks.
Thanks, everybody.
Thank you.